Okay, 5.3 notes, increasing and decreasing intervals. So it says, first, find the critical points of the graph F. So the critical points of this graph is going to be at all the places where we have a peak or a valley. Okay, so for example, we have a peak here, a valley here, and then notice if we were to take a derivative of this cusp right here, our derivative wouldn't exist, which means we have a critical point at that x value. So I have critical points at x is equal to 3, x is equal to 5, and x is equal to 6. When the slope of the function is positive, the function is increasing. Well, this is the same as saying if the derivative of f is greater than 0, this tells us that the function f of x is increasing. And then the opposite is true. If we have the derivative of f of x less than 0, then the function f of x is decreasing. Or in other words, if the slope of the function is negative, then the function is decreasing. So now that we established those critical points, let's look at the values surrounding those critical points. So for example, let's look at the intervals of each one. So since our first critical point is 3, then I'm going to say that my first interval is from negative infinity to 3, which means my critical point is at 3. And then my next interval will be 3 to 5, critical point 5. My next interval would be from 5 to 6, critical point 6, and then 6 to infinity. Okay, so within each of those intervals, I'm going to pick a value to see if the sign of the derivative is positive or negative. So let's go ahead and pick values. Let's see, we could pick 2, 4, 5.5, and 7. So then looking at x equals 2, that's right here, notice that this slope of this line is going to be positive. So that means the sign of the derivative is positive. Okay. The sign of the derivative at 3 is 0 because of that 0 slope. Then we check 4. Notice that if we look at 4, that's right here, this is now looking at a negative slope. So we write negative. 5 is 0 because of this 0 slope. 5.5, which is right here, is a positive slope. 6, the slope would not exist, so we would say undefined because of that cusp. And then for 7, we're right here, which is going to be a negative slope. Okay. So notice that each of the signs of the derivative is going opposite. So we had positive, then negative and positive, and then positive and negative surrounding each of those critical points. Okay. Number 1 says, find the intervals on which the function f of x is equal to negative x squared minus 4x minus 1 is increasing and decreasing. Justify your answers. So the first thing we have to do is find the critical points. So we find the derivative, and we get the derivative as negative 2x minus 4, and we set that derivative equal to 0. So I can take it a GCF of negative 2, and I'm left with x plus 2 equals 0, which means I have one potential critical point at x equals negative 2. Then it says, in between the x values, the derivative must be positive or negative. So in other words, we're looking at our intervals. Well, since I only have one critical point, I'm going to have the interval before that critical point, so negative infinity to negative 2, and the interval after that critical point, so negative 2 to infinity. It says we can use the chart to help keep track of information. Write the critical points of the derivative first. So what that means is I'm going to write my -2 right here in the center. This is my first interval. This is my next interval. And I'm going to pick a number within each of those intervals. So for example, I'm going to pick -3 and 0. Okay. So then I am going to take that -3 and plug it back into the derivative to see if I get a positive or negative value. So f prime of -3 is equal to -2 times -3 plus 2, which gives me -2 times -1, which is positive. So I have a positive value here. And then I'm going to try 0. So f prime of 0 is equal to -2 times 0 plus 2, which gives me -2 times 2, which is negative. Okay, and then remember, we got -2 because we set our derivative equal to 0, so this sign is 0, means there's a 0 slope at that point. Okay. What's also nice is we're able to get a nice image of what the graph would look like without having to graph it, because these signs of the derivative is telling us potential slope. So it's saying we have a positive slope before we have a 0 slope and then down to a negative slope. Remember, our function was -x squared, which makes sense that we have an upside down parabola. Okay, the last part says answer statements with a justification. So we would say that the interval -infinity to -2, f of x is increasing since f prime of x is greater than 0, or in other words, it's positive. Then we would say the interval -2 to infinity, f of x is decreasing since the derivative f prime of x is less than 0, it's negative. Okay. Number 2 says find the intervals on which the function is increasing and decreasing and justify your answer. So the first thing we have to do is take the derivative. So f prime of x is equal to x squared minus 2x minus 15. Then we're going to set that equal to 0 and solve for x. So we're going to have to factor this. X minus 5 times x plus 3 equals 0, which means I have x equals 5 or x equals -3. Okay. From here, I need to establish my intervals and write down my critical points. So I have -3, and then I have 5, which means my intervals surrounding that would be -infinity to -3, -3 to 5, and 5 to infinity. And I would pick a number within each of those intervals to test with my derivative. So I could choose -4, 0, and 6. So then what I do is I would plug those x values into my derivative. So I have f prime of -4 is equal to -4 minus 5 times -4 plus 3, which would give me -9 and -1, so that's going to be positive. Okay, then I'm going to check f prime of 0, which is going to give me 2, which is positive. Oh, sorry. I plugged it into the wrong one. F prime of 0 is not going to give us 2. It's going to give us -15, which is negative. And we know these are zeros because there are critical points and we set the derivative equal to 0. And then I'm going to do f prime of 6, and I get 6 minus 5 times 6 plus 3, which is 1 times 9, which is positive. So again, I can get a nice depiction of what the graph would look like based off of this table. So I have a positive slope, a zero slope, a negative slope, a zero slope, a positive slope. Okay, and notice that each peak and valley I had a critical point. So critical point at x equals -3, and then a critical point at x equals 5. So for my justification, I would say on intervals -infinity to -3 and 5 to infinity, f of x is increasing since f prime of x is greater than 0. It's positive. Those were two intervals in which my sign of the derivative was positive. Then I would say on the interval -3 to 5, f of x is decreasing since f prime of x is less than 0. Okay. Now it says graph the derivative of f. Is f increasing or decreasing? Oh, sorry, graph of f prime of x. It gave us the derivatives graph. It says determine the intervals where f is increasing and decreasing based on the graph of the derivative. Okay, so since this is the graph of the derivative, we know that all the places where it's above the x-axis, it's increasing, and all the places where it's below the x-axis, it's decreasing. So if I was to color code this, I would say increasing would be from here to here, and then here to here, and then decreasing would be from here to here, and here to here. Which means I have the increasing intervals from -infinity to -3 and 1 to 3, and then my decreasing intervals from -3 to 1 and 3 to infinity. Okay, and then last part here says application of rate of change. It says if you want to know if something is increasing or decreasing, you look at the sign of its rate of change. The sign of the rate of change can tell you if the dependent variable is increasing or decreasing. Interpret the following. So each of these are rate of changes. Okay, so we have students per year, miles per hour, mastery checks per week, and virus cases per month squared. So based off of if this is positive or negative is going to tell us if our function is increasing or decreasing. So since this one is greater than 0, we know that it's increasing. This is less than 0, so it's decreasing. Greater than 0, so it's increasing. And less than 0, so it's decreasing. And then lastly, it says the rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by r of t is equal to 2t cosine t squared flies per day. Show that the number of flies is decreasing at time t equals 3. So our first step here would be to take the derivative. So r prime of t is equal to, and notice here we're going to have to use the product rule and the chain rule. So this would be 2 cosine t squared plus 2t negative sine t squared times 2t, okay, which simplifies to 2 cosine t squared minus 4t squared sine of t squared. Let me just move this. Of sine of t squared. Okay, then it wants us to plug in 3 into the derivative, and then we're trying to see if we get a positive or negative value. So r prime of 3 is equal to 2 cosine 3 squared minus 4 3 squared of sine 3 squared. Okay, typing this into the calculator, or Desmos, we get approximately negative 16.65, which we see is negative. Okay, so since it's negative, we can say that the number of flies are decreasing at time t equals 3 days. So the number of flies are decreasing at t equals 3 days since r prime of t is less than 0. Okay, and that would be our answer.